Cool, cool. We will unmute. We will crank that soldier boy. Are we live? Oh, there we go. All right. Oh, I guess we're not ready. Well, no one actually knows.
Hey, Evan, pull up twitch.tv/RIT so next to live.
Are we live? We are live. That is wonderful. Woo! All right, welcome everybody to week 11 of RITSec. Who is hyped? Wow, that was pretty underwhelming, but that's all right. So, because our redirects often failed, I went to Matt Brown and said, Matt Brown, can we get a cool page that has all of our links listed so everyone can just click on the link to sign in instead of trying to type in signin.ritsec.club and wait for the redirect to not work? Well, he came through. So if you head on over to our, please move. Why? It's not moving. I have it pulled up. There we go. Our fancy new sign-in page, you can find all of our relevant links, including the weekly sign-in, all of our interest group sign-ins, and other helpful links. We can update this pretty quickly, so if you want to add a link up here for something that you are a part of that's officially sponsored, I guess, hit us up. We'll add it up here. And it's going to hopefully fix our problem. Look how fast that was. Love to see it. Cool. Now let's go back. All right, while you're signing in, let's thank our sponsors. We love them. Without all of them, we couldn't do the wonderful things that we do. Oh, words are hard. Yeah. All right. We have a message from Quentin about the CTF. Soon, TM signups will be open at ctf.ritsec.club. When this is up, if you've done the weekly challenges before, it might look very familiar because it's the same platform. But with your teams of up to 5 of RIT people, you can be eligible for some pretty cool prizes. I am positive that a link will be plastered all over Workplace once this is up and ready to go. But you have it here first, so when it's ready, you can head on over there and sign up for our CTF. Ooh, I did this out of order. That's funny. Our social media is pretty poppin'. You should follow us. I don't know. I can only say the same thing so many times. If you're not following us at this point, you're probably not going to, but you should anyway. All right, standard disclaimer. All the things we do here are educational. We want you to learn, not be bad people. So as always, be good, not bad. All right, we have some challenge presentations this week. Our first one is from Malik. So come on up here. So just get yourself mic'd up for the stream and take it away.
All right.
Well, it looks like it. There you go.
All right.
Definitely works.
Hello, everyone. Let's go over it. Who am I? I'm Abdulmalik Banasser, aka Malik, to make your life easier, known as Mr. Hunter. And I did the medium 2 for this week. And as we can see, like when you just sign to the port 19999, we have a secret meme factory. When you try to log in with any users, it just tell you, sorry, the user is already registered. So I just went to Burp Suite to see what's going on. And when I captured that or intercept that, I got the XML tag, so I know it's XML version of the website. So I looked up XML injection, so I found XXE injection, and after some search, I just got the like this example of the code, and I tried it in the Burp suite. I just like make it clear that I separated the lines. I added there, and I didn't know which line gonna execute the code, so I just like put all of them, so I can make sure. So when we just run that command, it gives us like the direction of the route and that stuff. So I just go back to the challenge itself. It said like the flag is in flag.txt, and I changed that to flag.txt, and here we go. We got the flag. And that preset.
All right, thank you, wonderful job. Next up, we have our very own junior tech lead, Emmanuel, giving a presentation on Medium 3. Yeah. There's your mic.
Okay.
Take it away.
Okay. This was supposed to be easy. Who am I? Emmanuel. Also potato, Pablo potato, or sweet potato. Doesn't matter. So if you go to the page, and if you look at the page source, there's a wonderful message that says it's run by PHP mailer. And if you look it up, it's actually a vulnerable service. It's a vulnerable service right now. So yeah, it's vulnerable. And so we can look up the exploit code, and there's this reverse shell we can use, and just change the IP address to yours and listen, and you get a shell, and that's supposed to be really easy. And if you do MD5 sum on the index.php, that would be your flag. So that's it. Thank you. I know.
What do you get? Are you asking for a lanyard? Unbelievable, unbelievable. All right. Oh, hate to see it. That's right, we did discuss that. All right, so without further ado, we're going to jump into Cloud Week with our very good cloud boy, Nathaniel Beckstead. You've seen his talks on random AWS things before. Now he's going to give a full-on education talk. Here you go. Take it away.
Thank you.
Oh, he's not ready.
All right, let's get right into it. All right, are you all ready to get learnt about cloud? So I would encourage you to listen closely, because I'm going to tell you everything they don't teach you in class, which is everything about cloud. I think I've had like one lab that was like network services or sysadmin that was like spinning up EC2, and that's been my cloud education at RIT. So hopefully we'll learn a little bit more this week. So first, I talked about this before, but this is the less cool version. Last time was pizza as a service. So one of the big overarching themes about cloud is there's these different as a service types. So like your traditional IT, you buy the servers yourself, you provide the electricity and the cooling for that, and in the cloud you don't have to do that. So the base version is infrastructure as a service, where you get the operating system and you can do whatever you want with that. And then you go to platform as a service, where it gives you some applications. So you can think of like Kubernetes, where you're managing Docker containers. That's like an application that runs on an operating system that you're given to do whatever you want with. You can run whatever containers you want. And then there's software as a service, like the Duo two-factor that we use, Office 365, stuff like that, where it's basically just a website that you're managing. So there's a bunch of different cloud services. We're just going to talk about like the cloud hardware providers, like Office 365 and all that's also like cloud stuff, but that's not really cool to talk about as a college student. That's like enterprise IT stuff. So there's three big ones: Amazon, Microsoft, and Google. And They're all kind of the same, but they have their own little takes on cloud and what they're trying to do to get into the market. So AWS is the biggest, and I view it as great for developers because it makes it really easy to spin up resources, put things together, and build an application. That's why it's really cool with startups, because it's really fast to build scalable architecture and get your application running. I think Reddit entirely runs on AWS now. Everything except the Netflix actual video streaming, so like the website and all that, their analytics all runs on AWS. And I think Lyft had a contract for like 300 million over the next 2 years. So they're really working with some like big technology companies hosting their infrastructure for them. Azure's cooler for sysadmins. Obviously, since it's a Microsoft product, works really well with Windows, Active Directory, that kind of thing. So if you're looking to outsource that stuff and make it like a global infrastructure, they're really cool for that. And then Google, they're like, I don't know, Microsoft and Azure, or Microsoft and Amazon are really competing for the top spot, and then Google's just kind of there. They do stuff with AI, like machine learning's all their thing. But other than that, they're cool backup if you want to like have some redundancy. So my experience is mostly with AWS because they give me the most money to do stuff with. And they're like the top dog right now. They have like, I don't know, 30 or 40% market share or something like that. And they all do kind of the same stuff. So everything I talk about in this talk is going to have some like Microsoft Azure equivalent. It just goes by a different name. It still works basically the same way. So first we're going to talk about building on AWS, because that's what I do most of. I don't really secure my stuff. That's more like an enterprise thing. So the top three like platforms that you would use, or categories of tools that you would use, are compute, storage, and database. So compute is where you're like actually running code. So the thing we think about the most, you may have some experience with if you've done that sysadmin lab, is EC2, which is Elastic Compute. Did we say cloud, something like that before? And it's basically a virtual machine in the cloud. You pick your operating system or a customized AMI, which is like a prepackaged image, and you can log into it remotely, and you have an operating system at your hands. Containers run on ECS and EKS, which basically manages your container. ECS is a little bit easier than managing a full Kubernetes stack. But yeah, you can just, if you don't need like the full operating system and you just have a container you want to spin up, it's good for that. And then if you just want to run code, you literally just upload a zip file of like your Python code to Lambda, and you hit run, and it runs your code. And that can be triggered. It's serverless functions. So it can be triggered by a bunch of different stuff, and just runs your code one time. That's it, and it does some cool stuff. Storage, S3 is probably the one you've heard of before. It's block storage and is like a key value thing, but really it just lets you store bytes. People use it for a bunch of different things. Yeah, like I said, it runs static websites if you want. People use it as a data lake, just like cramming data in for big data stuff, or just as a file server. There's also a thing called Elastic File System, which is like a network file system, NFS, for EC2. So you can have like remote files shared between EC2 instances. And then there's databases. So RDS is like your traditional MySQL, MariaDB, that kind of thing. Those run on EC2. You just don't manage that yourself, and you're given a login to the database, and you can do whatever with it. DynamoDB is Amazon's NoSQL database. So you don't have to write like structured tables. Like you don't have to say, I have an integer in this column, string in this column, whatever. You can just cram data into that, and it's super fast. They say microsecond response times, even for millions of queries a second. And then Redshift is like their big data warehouse kind of thing. You store a bunch of data in it, and it's pretty cheap. So let's get into, there's like a million different services. I think there's like 170 or something. And they all do weird stuff. I just saw a tweet about ground station, and NASA is using it to communicate with one of their satellites and like automate some analytics and like big data stuff in AWS, which is pretty cool. They're doing like space science in the cloud. And they also have like normal enterprise stuff. What?
How do you do space science in the cloud? They're like an atmosphere.
Yeah, so it's like less latency, I guess, than doing it on the ground. So yeah, you have less distance. It's probably like a microsecond faster. They also have like enterprise IT stuff. Like they have their own version of Google Docs. I think it's just called Work Docs. They have video conference stuff if you really hate yourself. That's called Chime. And now they just started AWS IQ, where you can hire AWS certified people, like basically contractors, to help you with your architecture, like to build an app real quick, stuff like that. There's a million different services, but we're just going to go over a few of the basic ones that you really care about. So first, like I said, with compute, Elastic Compute Cloud is like the big moneymaker and like majority of their platform usage, I guess. Because if I'm an enterprise, like I'm used to running my own servers. So if I want to make the move to the cloud and look all cool, I'm just going to fire up some VMs, move my applications to that. I don't really want to worry about all this AWS specific stuff. So you can do whatever you want with it, run your web servers, databases, whatever you need. Then there's Lambda, which I talked about, running code. So it's really fast, and you only pay for that time the code is running. So rather than have an EC2 box constantly running 24/7 and then just waiting for maybe like a web request every 10 seconds or something, you can only pay for that time your code is actually like handling that web request and executing something, and then it stops, and you only pay for like half a second of time. Yeah, and it can also be triggered not just HTTP requests, but like if every time you put an object in an S3 bucket, you can run something for that object. Every time you push an AWS IoT button, you can run a Lambda code. It's like the dash buttons, but custom. And there's like 20 different triggers for those. Then I talked about Elastic Container Service, which is the less technical Kubernetes as a service stuff. So you can just give it some parameters, and this also runs on EC2. A lot runs on EC2, you just don't see it. And you can spin up your containers without having to worry about like running Docker or Kubernetes. Storage, S3 is super cool. You just like create a bucket and you can just upload files to it, and it's really cheap. It's like, I don't know, 1/1000th of a cent per gigabyte just to store it. I don't know. I don't even look at my bill for that because it's normally less than 1 cent, sometimes 1 cent or 2 cents. It's really nothing. And so if you have a bunch of big data and you just want to throw it in there and use it later, S3 is probably the way to go. And like I said, you can use it. They have just an option you can click in the bucket to make it a static website. And there's a few other things, but it's really just like a general purpose storage system. There's also Elastic File System. So if you want to share files between multiple EC2 instances, you can create that. And it's just basically a networked file share. Then Elastic Block Storage isn't really a service, but it's what runs all of the like hard drives of your VMs. So you have EBS volume, which is attached to a EC2 instance, and you can actually remove that and attach it to a new instance too, which is really cool. And it does some cool stuff with forensics if you're interested in that, where you can just like get a copy of the EBS volume. Next, databases. So RDS, traditional databases, you just basically get a login to an IP or a domain and a port, and you can do whatever with it. It automatically does your backups, it automatically scales, that kind of thing. So if you aren't really into actually like managing the database, it does it for you, which is cool. DynamoDB, like I said, is super fast, and rather than like having to connect to a port, you can just use the AWS API and be like, I want to put this data in this table, and then it automatically does it in like one line of code rather than connecting, writing like a request to that. It does it all for you because it's an AWS product. Elastic Cache is like your in-memory data caching. So it's super fast. It's like their take on Redis or Memcache. Redshift stores a lot of data for data processing. They're trying to get into AI and big data a lot, which is one of the big benefits of cloud because you can harness all this resources that you need maybe for like 20 minutes to run some compute stuff. So if you're running like big data, you only pay for that rather than having to contract out an entire data center that you only want to use for 20 minutes. Then MapReduce is like your Hadoop. So that's like a big data compute platform, and they have like an AWS version of it. I gave a talk about this before. It's like the big thing that people get wrong, I guess, in the cloud. So it stands for Identity and Access Management. Basically, it controls your users and your access permissions. So a lot of people want to like just give me the root user and I'll do whatever. And that's not really good. So in AWS, it's really easy to control like fine-grained permissions. There's a ton of different policies for like very small things, and you control what a person can do, what action a person can take on a resource, and you can make sure that your permissions are totally locked down. So ideally, that's how you would use it. Doing that manually is very hard and time-consuming, which is why a lot of people don't. So this is like where your focus wants to be when you're securing the cloud. We're going to talk about that a little bit, or go back to my talk specifically about IAM. This is also where you manage your API keys, which is a big thing. Most people don't use the actual like web console for managing AWS. A lot of it is through the AWS CLI or some other API tool. So like a lot of companies will be like, just give us, connect to your AWS account and we'll manage whatever you want. Most people don't like actually, when they want to like spin up a database, don't actually go into the console and create it. They just have some other tool do it for them. So API keys are made of your access key ID and a secret access key, and those go into a configuration file, and you can use the AWS command to just do basically anything you want. Any action you want to do in the web console, probably like 99% chance has some kind of API action that you can also take. Another thing with IAM is the Metadata Service, which I just found out, I don't know, a couple months ago because there was a big breach with Capital One. And I was like, wow, this is a really cool feature, but also like a bad feature from a security perspective. So if you're on an EC2 instance and you curl 169.254, 169.254, you can get a bunch of information about the host that you're on, which is really nice when you're configuring things at a big scale, like you probably are if you're using AWS at an enterprise. You can get the public IP address, the host name, the instance size, like how much hardware it has, and things like that. And that's really useful from a development perspective, and also from an IAM perspective. Rather than storing your keys, like your API keys that you get from the IAM user in your code or on your box, you can just curl 169.254, 169.254, and if that instance has a role attached to it, you can get temporary tokens that you can use. So rather than storing them in code, you can just curl this when you need it, and you have a fresh set of credentials that are rotated every few hours. That's really cool, but if you're able to make requests from that box anyhow, you can get those keys, and they aren't locked to that instance. I, as an attacker, if I can make a request from that box to 169.254, I can use those same keys on my box and access that account for, I think it's like 6 to 12 hours. I'm not sure the exact amount of time it's rotated. And then I can basically do any permissions that that role gives for that EC2 instance. So in the case of Capital One, they had a server-side request vulnerability in the firewall that was running on EC2, and it somehow had access to all of their S3, it had read access to all of their S3 buckets, which just happened to have a bunch of credit applicants' data on it, including 100,000 social security numbers. So this is a pretty big vulnerability that you have to look out for and make sure that this metadata service is locked down and you're doing your permissions right, because it can lead to big breaches. So how do we connect all of these resources together? This is like your networking, but in the cloud. So EC2 instances sit in a VPC, which is a virtual private cloud. And they're basically just like a private network. You get a CIDR block of private IP addresses, and they can talk to each other if they're in the same VPC. There's also security groups, both for a VPC, so it's like basically a firewall sitting at the edge of your network, and also on the instance. Yeah, like IP tables basically, but managed. There's also a CDN called CloudFront, which can be cool for managing globally or like dispersing your content globally. Route 53 manages DNS, and then API Gateway has like a really cool graphical interface for creating an API and connecting it to different resources. So VPC, like I said, basically a private network. So you have a block of private IP addresses, and that's cool, but then you have to add an internet gateway to actually give it internet access, and that will pool public IP addresses for each of your instances, or have one public IP for a bunch of private IP addresses behind it, depending on how you set it up. I don't really use VPCs too much because most of my stuff is just a single EC2 instance acting independently. I don't set them up to like communicate together. But there's a default VPC that just manages that for you. So it gives you a private or a public IP every time you create a new EC2 instance. So I don't mess with this too much. But if you're an enterprise and you want to do load balancing, you can put a load balancer in front of it and distribute traffic to each of those instances in a certain VPC. Route 53 is a distributed DNS service, so you can even buy domain names or just transfer the name servers to Route 53, and you can manage your DNS through Amazon instead of Namecheap or something like that. And it makes it really easy for connecting subdomains to different resources. So I can just link a subdomain to a certain S3 bucket in Route 53, and rather than like have to get the IP address and configure S3 through that, I can just say, connect this subdomain to this resource, and no matter what the IP can change, whatever, it still routes correctly. And fun fact, Route 53 is the only service that has 100% uptime SLA. So most times they'll guarantee like 5 nines, like 99.99999% uptime, which is like 5 minutes of downtime a month. But route, oh yeah, yeah, that's right. And they actually guarantee 100% uptime with Route 53 for some reason. I'm sure they're justified in it, but that's just crazy to me that they're like we will never go down with this service. Except it did have a problem a couple weeks ago with like some DDoS attack or something that slowed it down. But they're pretty confident in that. CloudFront will disperse your traffic basically. So I have an S3 bucket with a static website, but someone from Singapore wants to access it, and my bucket sits in the Virginia data center. That takes a really long time, and I'm all about being cloud scale, being fast, being scalable. So CloudFront will automatically disperse your traffic or your content throughout their CDN, and that person, no matter where in the world, can access that data at the nearest spot closest to them, which is really cool. And it can also do some cool stuff with like domain fronting, if you want to look into that from a security perspective, where you're hiding your actual like EC2 server, malicious server, through a legitimate service like CloudFront. And then API gateway, like I said, makes it really easy to make API requests and design an API. And you can basically translate HTTP requests to a domain, to Lambda functions, database queries, a bunch of different stuff. You can actually make an entire API that, without writing any code, you can just have API requests translate to database queries for like putting data, getting data, and you don't actually have to write any code. So if you're not into your programming, you can still make cool stuff using AWS. That was basically how to build applications on AWS, but there's a lot of stuff with security that people don't take into mind when you're putting your information out into the cloud. So we're going to talk a little bit about how we can secure these resources once they're up. So first off is security groups. So like I said, it's basically like putting a firewall out in front of your VPC or your instance. And it's pretty primitive. It's just filtering based on the source IP address and the destination port. So like by default, the default security group allows SSH from anywhere, because you kind of have to connect to your box, and allows all outbound traffic. But obviously those should be hardened down, and you can actually have multiple security groups for one instance. So you can create general things like if you're allowing SSH or allowing WebAllot, you don't have to create a single security group for a single instance. You can actually just attach the SSH security group and the web security group, and makes it pretty easy and manageable. I have a ton of different security groups, I think like 65, that are just not attached to an instance anymore, and are just kind of like taking up space, and it looks really ugly when I have to manage something. And then there's also at the VPC level, so I don't trust my developers with like creating their own security groups, so I'll just manage it at the VPC level, and any instance in that VPC has to go through this security group as well. So there's a ton of different security products or services in AWS. Two of the big ones are CloudWatch, which isn't really security, but it can be used for security. It's basically resource monitoring, and you can send whatever kind of logs you want through CloudWatch. And there's a bunch of companies and services that will look through those and look for attacks and do that kind of thing. But CloudTrail is specifically meant for security and monitoring API activity. So every action that you take either in the console or in the API will be logged in CloudTrail if you enable it. And you can detect things like stolen API keys or misuse of API keys. So suddenly Joe spun up 20 giant EC2 instances, and they're at full CPU capacity. That's probably suspicious. Someone probably got a hold of his keys and is mining Bitcoin now. Trusted Advisor basically audits your configurations of your entire AWS account and will look for misconfigurations that may lead to security vulnerabilities. So it looks for overprivileged accounts. So it says like, hey, this user has administrative access to everything. You should probably lock that down to these certain things that they did in the past year. It also looks like, has recommendations like you should enable multi-factor authentication on your accounts, or your security groups are just allowing everything through. You should probably lock that down. So it's like a very fast audit of all of your resources. Certificate Manager manages your certificates. So like your TLS certificates, when you're like creating a website, if you still use that and you don't use Let's Encrypt, it'll manage that for you and have kind of like recommend, hey, you should rotate these, or you can rotate them automatically, I think. AWS Config looks for resource integrity, which is really cool. So you can have like an ideal configuration of your resources, and when that changes, you can be alerted to it. So maybe I know I want these EC2 instances, their security groups should be locked down to these ports. If someone opens that and like adds a new rule to that security group, they can alert you for that. Guard Duty is like their big security product, but it's basically you feed it a bunch of logs and they do some cool machine learning IR detection stuff to figure out if you're being hacked, basically. So kind of you feed it CloudTrail and CloudWatch logs, and it has a bunch of different detections. I saw a few recently updated. One was for like insider threat detection of making S3 buckets public. So they're really going hard on the security now in AWS, and Guard Duty is kind of like their main product for that. And I'm sure it's very expensive, but it does some cool stuff. And then Inspector is like their network security product. So it actually like looks at the network for between EC2 instances, for example, and looks for vulnerabilities or exfiltration of data, maybe. So if a bunch of traffic is leaving your S3 bucket, that might be a bad sign if it hasn't happened in the past. So web application firewall is basically like any other web application firewall, but it integrates with AWS resources because we love AWS. You should too, and you're going to use everything AWS and give us more money. So it can be deployed as part of your CloudFront CDN, which is cool. So rather than sticking your WAF in front of an EC2 instance or a load balancer, you can just deploy it with CloudFront, and it manages all of that for you. It does the same thing for API gateway, or it just sits on EC2. And it has a bunch of rules that you can implement, but you get charged per rule. So maybe I'm like running low on money. I don't have a huge budget. I'm like only going to detect XSS, and that's it. So that's one thing we'll talk about later is like everything has a cost. So I might not do the best security possible because it's going to cost me a ton of money. So that's one example of how it can cost you money to do security well. AWS Shield comes with most AWS resources by default for free, which is cool. So they do basic DDoS protection, which is like your very basic DDoS protection of just like SYN floods and that kind of thing. And so if you're being DDoSed, they'll prevent that. That's for CDN, API gateway, EC2 instances. Basically everything has some kind of DDoS prevention in front of it. But if you want the premium stuff, which they actually have a DDoS response team 24/7, and they also do forgiveness. So if you like so AWS charges for your network traffic, and if you're suddenly like getting tons of requests and from a DDoS, and you rack up like $20,000 in network charges, they might forgive that if you have the Shield basic or premium plan. They'll be like, no worries, it wasn't your fault, here's your $20,000 back. And then Secrets Manager, I'm still figuring out, but it's really useful for just storing secrets. It's their version of a vault. So like a bunch of different companies have vault programs, but rather than putting my credentials in code or like environment variables, stuff like that, I just make a request to Secrets Manager and get temporary credentials back without having to like worry about how do I store these securely. But these aren't for like your IAM keys. That's a whole different thing with the metadata service. This is more for like your API keys for some other service or just sensitive data that you want to put. Finally, they're really pushing the marketplace now. So a bunch of third-party companies have started selling security products on the marketplace. So Fortinet, Palo Alto, Symantec, Cisco all have like firewalls and other like IDS, IPS software that you can purchase directly from AWS, and all that licensing is managed for you. So you don't have to deal with like 20 different salespeople. You can just buy it through here. And this is like a big thing. They're pushing at Reinforce, and everyone's trying to get into the cloud. And this is their way of like making it easy for you to both like the seller to get into the cloud marketplace and the buyer to secure their cloud. So like I said before, a bunch of this stuff is managed through other tools, not just the web console. So CloudFormation is AWS's version of infrastructure as code. So I can write a configuration file. I think it uses YAML. And basically like define, I want an EC2 instance with this security group, give me a public IP, put it in this VPC, so on, and you just run that code, and it'll create those resources for you. Terraform is kind of like the open version of that, run by HashiCorp, and that's a cloud agnostic thing. So it has modules for AWS, Azure, GCP, VMware, ESXi, OpenStack, a bunch of different stuff. There's a Terraform module for ordering Domino's Pizza while your resources are deploying. Yeah, so I have a Terraform configuration. I want to spin up like 20 EC2 instances, but that's going to take a little bit. I'm getting hungry. It's like 11 p.m. I'm a sysadmin. Just throw in a line of order me a pepperoni pizza too, and it'll do it. I've been using Terraform a lot. It's intimidating at first. It looks kind of weird, but once I started using it, it's really nice for, I've been using it for projects just to have like an example infrastructure set up. So in my GitHub, I also add a Terraform configuration. I can just say run Terraform apply, and my project's set up for you in AWS, which is pretty cool. They also make Packer, which is an image creation tool. So I talked a little bit about AMIs before. That's basically a machine image, like an operating system packed up into an image that you can deploy. And Packer will create those images for you. And it can do VMware, VirtualBox, and cloud AMIs all at the same time. So I can have the same operating system deployed on any of these using different images, and it automates the whole thing. Ansible is a tool we may have talked about before. It's really cool for automating stuff, not so much actually creating infrastructure though, more for like doing tasks that you want a lot. So I don't know, like auditing your security groups maybe and looking through those. I tried to use it for creating infrastructure this summer at my internship, and it was all right. Like there's a ton of cloud modules for it, and you can do it, but it's a lot harder than Terraform, which is kind of built to do that. And then finally, here's example infrastructure. Like how does this all come together? So we'll stick a load balancer up front and then have a bunch of web servers running on EC2. And then that's in a public VPC. And then we'll have some private subnets where our databases sit, our S3 buckets, and whatever private resources we need. And our web servers can access that and then relay the data back out publicly. So speaking of EC2, a bunch of mistakes that are made. Obviously, just like allowing everything through your security group is pretty bad. You should definitely lock those down when you can. I don't do it a whole lot because I move around like home to college, to internships, whatever. It's kind of annoying when I have to change security groups. But if I know I'm going to be at RIT for a lot, I do lock it down to 129.21 subnet. And then one thing I just learned about is you can actually make snapshots of your EC2 instance public for some reason. So you can take backups and snapshots of your instance, which is basically just like a copy of the drive. And anyone can view those snapshots if you make them public. And those could have credentials in them and your like configuration files or your application, your code. But luckily, they do default to only accessible by the current account. So you really have to try to make them public. And also, obviously, access to the metadata service. That's not something you can really prevent because it comes with every EC2 instance. But there are tools to lock it down, like with IP tables that'll automate that. I'm trying right now to lock it down by process using IP tables too. But if you don't need it, just block it. It's a risk if you are using roles and credentials that those could be leaked. So S3, the thing like everyone likes to make fun of like why were they making 100 gigabytes of sensitive data in a public S3 bucket? But it's actually really hard to figure out S3 permissions. There's object level policies, bucket level policies, access controls for both buckets and objects too, and IAM policies. There's like 10 different things you have to manage and get right to actually set up your stuff securely. So if you want to make it public, you're probably just going to make it public to everything. Don't deal with it. But there's a few tools that can help with S3 permissions, but it's still just a mess, I think. It's pretty hard to actually make things secure in S3 while still having some public access. One thing is buckets with the list bucket policy attached will let you list every file in the bucket, whether it has like the get object or not. So you can see some sensitive stuff if that's not configured correctly. And also if you're using GitHub or any kind of Git like version control to like upload some stuff to S3, you may have your .git directory exposed in your bucket, which can have some like sensitive credentials in it. And anyone can kind of look at your Git history if that's open. And then just like general cloud stuff that people struggle with, it's a common problem just with any cloud provider, any company. Obviously, API keys are like the key to your business in the cloud. And so those can get stolen if they're just like published to GitHub, whatever, and anyone can use those keys to act as you, which doesn't really have too many consequences if it's just like, I don't know, like you're showed an API key or something. But this is like your business we're talking about. So stolen API keys that have a lot of credentials or like permissions attached to them can like lead to, like I said, like Bitcoin miners being spun up and costing you thousands of dollars, or just your company just straight up being deleted, like I talked about in the last one. Overprivileged users are also a big thing. because there's so many tiny actions that you have to add, like they call them policies, and to get that right is really annoying. So I'm probably just going to add like the general read permission or write permission and not really lock that down. There's a bunch of cool tools now. RepoKid by Netflix is the big one that will start you out with broad permissions, and then as you use it, start to take away permissions until you have a role that fits exactly what that application is doing. Obviously, like I said, everything costs money in the cloud. Like you're being charged for every gigabyte of traffic that goes between data center and the internet. So you might think, like, I'm just going to spin up an EC2 instance, throw my application on it, and now we're in the cloud, we're scaling, we're doing cool stuff. But there's a lot of hidden costs, especially with AWS, and you might want to enable CloudTrail, but that stores logs in S3, and that's going to cost you money. Every time you want to do some actual like computation on it, you're going to have to download those. That's going to cost you money. If you want all that managed for you and you spin up guard duty, that's going to cost you a ton of money. So you may not be thinking of everything when you're securing the cloud, and you may run out of money very quickly. And then one of the big complaints that people have is AWS is moving too fast, and things are changing all the time. Things are getting added. Like, I'm sure a lot of people still don't know about the metadata service, and if you don't know about that, that's just a thing that's there that that just kind of sits in the background. You don't have to know about it, but it's a risk that's there that you may not be thinking about. And there's people really winging it a lot of the time, especially like developers are really in control of the cloud now. So first of all, their security is not the first priority for them anyway. And then they have to learn all this cloud stuff too. And then they have to learn security and then cloud security too. So people are just kind of figuring stuff out as they go, and there's very few experts on the actual topic. So why learn any of this in the first place? Well, AWS has a whole conference around cloud security. It's called Reinforce. Their main conference is called reInvent. So this is specifically for security and security engineers, CISOs, and third-party companies that partner with AWS. I think they just had their first conference this June or July, but it's a pretty big thing, and they're really getting serious about cloud security and innovating in that space. I heard a CISO a couple weeks ago say, like, we pay extra for cloud knowledge. So if you want a nice little bump in your pay, learn some cloud stuff. It's a really hot skill, and it makes you sound cool too when you're securing the cloud. There's a lot of cool, interesting things around the cloud. It's not your typical IT environment. You're not going to have like buffer overflows and exploitation of your infrastructure. It's going to be misconfigurations, constantly changing infrastructure and networks and applications that you're going to have to keep up with. And if you're into automation, this is really the space for you. There's a lot of tools and like programs that you can use. People are developing. Netflix is a huge innovator in this space, as well as Duo Security. And they have a lot of like good security knowledge. So how do I get started? Well, you can create your account. I guess you can go to this link or just Google Amazon AWS, and you can create an account for free. You might have to put in a credit card number. You do. Yeah. Yeah. You won't get charged most time. I don't know. I don't think you'll get charged unless you're like really messing with stuff. But there's a ton of free tier stuff, like Lambda has a huge free tier, DynamoDB. EC2 lets you spin up a single instance for a year, every year. So you can like at least have one VM always running. And then they also have AWS Educate. AWS Educate is part of the GitHub Education Pack, which gives you $75 to $150 in credit for every year that you're a college student, which is really cool, and that's a lot of money in AWS. And you can also do courses and that kind of thing to get more money. And then if you're really interested, you can get this $100 a month thing for writing an AWS or Amazon Alexa skill, which is only like 15 lines of code hosted on EC2, and you get $100 a month. And that's basically unlimited funds for doing stuff in AWS. I think my bill right now is like $85 a month, and that's because I'm doing mentorship stuff and I have a lot of boxes, but it really is a lot of money. I talked about the API before. There's a bunch of different tools for it. There's a PowerShell, there's a Windows AWS CLI program, there's a PowerShell module, and then just your normal CLI tools for Mac and Linux too, which is how you'll interact a lot with AWS. So once you've created your account, you can grab your IAM keys. I would recommend creating an admin user that's separate from the root account, and then just disabling the root account basically. But I'm not the boss of you. Do what you want. And then when you get your IAM keys, you can run AWS configure on the command line, and you just input those keys and you're good to go. So once you've started, you can do some cool stuff. If you want to see if a website's hosted on S3, you can just do a dig, and it'll tell you the IP address, and then you can NS look up the IP, and it'll be like US East 1.S3 website, Amazon AWS.com, something like that. And then from there, you can use the S3 API on the command line to actually like look at that stuff. So ls will list the contents of that bucket. Sync will just sync with that bucket and download it locally. And then copy will also copy a single file or a directory. And another cool thing, if you get a hold of some AWS keys out in the wild, you can use AWS IAM get caller identity to actually like figure out the account that you're on, the name, and then from there you can go and get some new permissions. Finally, a few resources. CloudSploit does automatic auditing of your account, and it'll tell you kind of what best practices you are using and what you need to work on. Flaws.cloud and Flaws2.cloud are really cool CTF challenges that are always up and demonstrates basic, like really common security flaws. And I just walked through Flaws 1 last weekend, I think. It was really interesting. Like, I struggled with some of the more complex ones, but I learned a lot. Rhino Security's a cool penetration testing company with a focus in the cloud, and they have a lot of tools for enumerating things in the cloud and escalating your privilege, that kind of thing. Like I said, there's a PowerShell module, S3 API. AWS documentation is actually really good, and they explain a lot. And then there's a cool DEF CON talk about just cloud security myths and what you think is true may not be. Demo time.
Thank you. Nice job.